This is topic 5.9, and we're going to be connecting f prime, and f double prime. Let's go ahead and begin. For the function, and this is a cubic, f of x equals 2x cubed plus 4x squared plus 2x, use a table to help you organize and draw conclusions. So what we're going to be using is sign charts. Okay, so let's go ahead and find the first derivative. I'll let you do that. You can pause the video if you want. And here we're going to go ahead and set that equal to 0 and go ahead and get that factored. And you can pause that video while you factor. So here you can see that f prime of x is equal to 0 when x is negative 1/3 and negative 1. So let's go ahead and put those here, negative 1 and negative 1/3. Putting in some test values, we'll use 0 here, which is larger than negative 1/3, and plugging into this factored form, you'll see that f prime of x is positive. Okay, let's go ahead and use negative 1/2 and plug that in both of those, and you're going to get a negative and in the same manner a positive. Okay, let's go take a look at f double prime. So in f double prime, we have 12x plus 8. We're going to set that equal to 0. And you can see that the second derivative is equal to 0 at x equal to negative 2/3. Now, since this is a polynomial, we do not have any critical points where the first derivative is undefined, so we don't have to worry about that. Okay, so now let's go ahead and put negative 2/3 on this sign chart for f double prime. And if you plug in a test value of 0, you'll get a positive, and then a test value of negative 1, you'll get a negative. So let's see where we have f of x both concave up and decreasing. So what I'd like you to do is go ahead and plot all of the points you see here. So we have negative 1, and we have a negative 2/3. I'm just going to go ahead and put a point here. And then we have a negative 1/3. Okay? And then sometimes it's nice to have these little dashed lines here. Okay? So what is f prime? Let's fill that in first. So f prime to the left of negative 1 is positive. In between negative 1 and negative 1/3, we are negative. And then to the right of negative 1/3, it's positive. Let's do the same thing for f double prime. To the left of negative 2/3, we have the second derivative is negative, and positive to the right. So when is f both concave up and decreasing? Let's take a look. Concave up would be the second derivative as positive, but decreasing, the first derivative would have to be negative. So here we have it. So this is on the interval from negative 2/3 to negative 1/3. That's where that is. Maybe I should move that a little bit. So I'll write that whole sentence out. How about that? Okay, so that leads us to bring up speeding up and slowing down again, and we have talked about this one other time, but an object is speeding up if the velocity and acceleration have the same sign at some certain time, okay? And now, what about slowing down? That is if the velocity and acceleration have different signs. That is when we are slowing down. So let's go ahead and try example 2. A particle is moving along the x-axis with its position. So this is our position function. Find the velocity and the acceleration functions, and then we're going to describe the motion of the particle. So let's go ahead and find the velocity first. And we'll set that equal to 0. We have what? T minus 6, t minus 2. And so at time 6, t equal to 6, and t equal to 2, I'll just put those in order. Don't have to be. T equal to 2 and t equal to 6 is where the velocity is equal to 0. Now let's go and find the acceleration function, which is 2t minus 8. And the acceleration is equal to 0 at t equal to 4. Now, let's make one of those nice charts with time or t, velocity, and acceleration. And let's just go ahead and have 3 lines. And I will go ahead and again place these values of t, all of them. So there's 2, there's 4, and there's 6. So I'm going to draw these dashed lines. And now let's go ahead and talk about the velocity. And the velocity is 0 at t equal to 2 and t equal to 6. And so the velocity will be, let's plug in a value here beyond 6. We will have positive velocity. And then between 2 and 6, we will have negative. And then less than 2, you could use 0, we'll have a positive. Let's go to acceleration. And I could move all 3 of these up. Whoops. I'll move all 3 of these up just a touch so we have them sort of in the right area. And now let's go ahead and plug in acceleration. Now acceleration just changes at t equal to 4. So to the right of 4, we are going to have positive, and to the left, negative. So how could we describe the particle slowing down and speeding up? Well, the first thing we could do would be slowing down is where these signs are different, and speeding up is where the acceleration and the velocity have the same signs. So slowing down would be negative infinity to 2, and also from 4 to 6. Speeding up would be from 2 to 4 and 6 to infinity. Okay, so let me just put a square around that. Okay. Let's look at number 3. For the given function f of x, f prime and f double prime do not change signs. So whatever one of these are, the rest are. So you can see here f of x is positive. So obviously f prime of x is going to be positive, and f double prime is going to be positive. Let's see how f is changing. So is f increasing or decreasing? So as you can see here, the slope between these 2 points, change in y over change in x, it is going to be 1. And the slope between these 2 points, 4 minus 2 divided by 2 minus 1, is 2. And then the slope between these 2 points, 7 minus 4 over 3 minus 2, is going to be 3. So as you can see, f of x is increasing since f prime of x is positive. So all of those derivatives are positive. Now, how about concavity? Do you see that f prime of x is increasing? As t increases. So f of x must be concave up. Since f prime of x is increasing, and if f prime of x is increasing, that means f double prime is positive. Okay? So that concludes this topic.